morning, everyone. Good morning. Thanks for joining my talk today. My name is Pandy Knight, and I am the Automation Panda. Be sure to read my blog at automationpanda.com. Follow me on Twitter or X or whatever we call it now. If you just Google Automation Panda, you will find me. Currently, I work at Cycle Labs as principal architect, and I'm proud to say that Cycle Labs is located here in Raleigh. Whoop, whoop. Yes. What do we do? Cycle Labs provides an end-to-end test automation platform that targets enterprise software, specifically in supply chain and warehouse management. I put a bunch of stickers and postcards from Cycle Labs on the sticker table in the back, so be sure to check that out. They're all gone. Come see me. I've got more. As we all know, I also have a very cute dog. This is Suki, my French bulldog. She's 2.5 years old. I had to share pictures because we have guiding eyes for the blind service dogs here in room 3. And dogs are just the best. If you have any questions after my talk, you'll find me over there. Enough talk about me. Let's talk about test data. One of the toughest challenges in testing any software product is handling the test data. Am I right? Yeah, it's painful. Now, when I say test data, I'm referring to multiple things. Test data includes both the actual data in the product under test, as well as the data values used by test cases. As testers or developers or, platform engineers, we shouldn't underestimate the work to handle data properly. Good data is just as important as good tests and good automation. So in this talk, we will deep dive into the connection between product data and test case data. We will learn how to pick the right strategies for handling both, including how to avoid data collisions when testing. And so by the end, you'll know how to manage the test data nightmare for your own test projects, whether you are testing a React app, a Python project, some platform engineering internal service mesh, whatever fancy words you've got. So, we ready to learn? Yes. Cool. So, let's say we have an application to provide, or for a bank to provide loans. The bank could configure this application for many different types of loans, such as a home mortgage, if you happen to live here in Raleigh, a car purchase, let's say you drive a Volkswagen Beetle, or a student loan if you went to NC State. I did not, though. I went to RIT. All the information the bank needs to provide for these loans must be stored as data in the system. Each loan product is different. It comes with its own rate, maturity, and payment schedule. Banks must also store information about the borrowers, about the funding curves, about the profitability targets for loan opportunities. Anyone work in fintech? You know what I'm talking about? Maybe? Yeah. It's all fairly complicated. But testing requires that all that data already be present in the system as a prerequisite. We can write a simple test case to exercise the application behavior. Scenario, create a new loan application. Given the Chrome browser is open and the page for myloanapp.com is loaded, when the user creates a new loan application for a home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application probably needs several pages of information, but let's keep our example here simple. This test creates and submits a new home mortgage loan application for the user, who's the requester. There are many data points in this short scenario. Most apparently, there's all the user's personal information. There's the type of loan. There's also the record of the loan application sent to the bank. Furthermore, the reference number is shown to the user. The URL is configuration information. And the browser type is a test input. Test data is everywhere in this short, simple scenario. It is inextricable from the test itself. Without specific data, this test would be meaningless. Unfortunately, the term test data is ambiguous. We've applied it to both the product data in the loan web app as well as to various pieces of test case data that make even the most basic test work. Product data refers to real data living in the software system. For the loan web app, product data includes all the bank's product configurations and lending information. Test case data refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, test case data is a reflection of product data. Its values refer to entities existing in the product data. The two types of test data are separate but nevertheless connected. Distinguishing these two types of test data is important to avoid confusion. The dependency of test case data on product data can be brittle, though. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage application change? What if the loan is no longer called a quote-unquote home mortgage, but a quote-unquote personal residential loan? Even something as simple and stupid as a string-based name change could cause a test to break, and compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code, as we've already said. How do we handle both product data and test case data together? Are there strategies we can use to avoid brittle dependencies? So let's explore multiple ways to handle both of these. Unfortunately, there is no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. It depends. Yes. So let's start with product data. As previously stated, product data is any live data in the product or system under test. In simplest terms, it's everything in the database. We're talking things like user accounts, administration settings, product customizations, records created by the users, files uploaded by the users, all that jolly good stuff. In our case, for this loan processing web app, product data would include specifically user accounts, loan product settings, loan applications, and that behind-the-scenes bank data. As we said before, data must be present in the product as a prerequisite for most testing. And there are two primary ways to get that data in the system. On one hand, you can set up the data before running your tests. This would be static data creation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that this static data is already in the system and simply reference it. Static data prep is a good strategy for complicated data or data that is slow to create dynamically. For example, those user accounts may need email verification, so it might be easier for automated tests to simply use a set of pre-registered users than try to go through the flow of creating a user for each test. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests too. Static data may also become stale over time as data formats are updated or if data is time sensitive. On the other hand, you can set up data during test execution. This is what we will call dynamic data creation. In the example loan test case, the loan application document is dynamically created. The test doesn't reference an existing loan application. It creates a new one for the user. Dynamically created records avoid the brittleness of hard-coded references to static data. They can also be used exclusively by the current test case, protecting them from interruptions by other test cases or other users. The main downside of dynamic data prep is the execution time. It slows down your tests. Dynamically created data is essentially disposable as well. So, at some point, you should be cleaning up that stuff. Which strategy is best? Well, typically testing requires both strategies together. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop my test projects, I prefer to create as much data as possible dynamically per test case to try to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data, and there's a much lower risk of test collisions. So, how do we implement these strategies? Dynamic prep is pretty straightforward. The test case just creates the data it needs. This could be done either in the setup phase or the main phase of the test. Data creation could be as small as just setting up some variables, or it could be as big as calling APIs and making database queries. Static prep, though, must be done outside of test cases. And there's a few general strategies for it. Let's look at them in detail. The simplest data prep strategy for static prep is manual configuration. And that's exactly what it sounds like. Testers log into the system and manually create whatever records they need to be in the system. This could include creating users, config settings, or saving records. Nice thing about manual configuration is low tech. Anyone can do it. You don't need fancy or complicated tools. However, manual configuration is slow, and it does not scale well for large systems or large environments. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms or for maintenance. So, a better strategy might be automated configuration. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways, reusing UI interactions from testing, calling REST APIs, database injection, using tools like Puppet or Chef, or maybe some Gen AI tools around synthetic data. Ooh, Gen AI, back again. Automation could generate data deterministically or randomly depending on your needs. The main benefit of automated configuration is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. Unfortunately, automated configuration is not a free lunch. It does require extra skills, and the code for it must be maintained. If you want a shortcut, you could try to clone your databases. Cloning databases is easier than ever now with cloud management tools and containerization. You could maintain one database in a quote-unquote golden state and then create a copy of it or spin up a new container of it before you run your tests. Once testing is complete, the database instance could be deleted or destroyed. Granular cleanup would not be necessary. Database clones make it easy to copy all data at once without worrying about any damage that a rogue test could cause. But databases can have a lot of data. I mean, a lot of data. We're talking gigabytes of data. So cloning large ones may not be practical. Clones may also need extra refinement to scrub those special fields or that personally identifiable information. And you might need some extra logic to hook them up correctly. Finally, if managing real data is just too much of a hassle, you could mock your endpoints. Hey, this would completely remove dependencies on databases and even some of your services. However, mocks are not always a good solution. They often require a lot of effort to set up, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that tests will not truly be end-to-end in coverage. All these strategies can also work together. For example, you could use automated scripts to configure product data into a golden database, and then you could press a container image with the golden database that you spin up on demand. In another example, let's say you have a large testing environment, you could choose to mock certain endpoints while using real data for others. Synthetic data generation tools can also assist in any of these static data prep strategies. Many times we want to use production or production-like data in our systems to mirror the real world. Unfortunately, production data has problems. It's got all that personally identifiable information. We don't want to track it back. We don't want to violate GDPR or whatever else comes down the pike. So things like credit cards, social security, medical info, all that needs to be private, right? But if we choose to generate data synthetically, we can avoid those roadblocks, right? It's all fake data, but it's statistically accurate fake data. And we can say, I want this much or I want this much. Synthetic data generation tools are pretty darn cool. They're more than just like your little faker library. Now, there are multiple factors that should be considered when deciding the best strategy for static data prep. First of all, how big is your data? If it's small, then manual configuration may be sufficient. If it's large, then automation may be required. How fresh does the data need to be? If data is time sensitive, then automation will be needed to keep it up to date. How frequently will the data need to be updated? Again, you might want automated tools, or especially synthetic data generation tools. How difficult will it be to try advanced tricks like mocking or cloning databases? This may be especially difficult for old legacy systems. We don't all live in the idealistic, perfect world of wonderful platforms. Is there any bureaucracy in the way of automated solutions? Hey, it happens. I've been blocked from getting access to Jenkins servers at new companies. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for things like automation, database administration, or mocks? Skill level may be a barrier at first, but training and learning can help the team overcome any limitations here. Just need a little time. And finally, what is the cost? Each data prep strategy has a cost. Teams should do a cost-benefit analysis when making their decisions. So, that's how to handle product data. Any questions? Halfway there. What about test case data? Let's look at that next. Test case data is inherently part of test cases. So let's revisit our example test from earlier. As we saw before, there are multiple bits of test data throughout the steps of this short scenario. And they represent different types of test case data. First, let's look at this step. Given the Chrome browser is open. The Chrome browser is test data because it specifies the type of web browser in which to load this application for testing. This is what we call a test control input. It directs how tests will be run rather than specifying behavior. Theoretically, this test should run the same on any browser type, but the steps dictate that the test here should run on Chrome. As a recommended practice, don't do this. Test control inputs should not be hard-coded into your test spec or to your test automation code. Instead, they should be passed into automation as inputs. That way, your automated tests can be easily retargeted. There's a few ways to do this. A simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they're easy to write, easy to read, and easy for pretty much any programming language to parse. They also have line-by-line diffs if you're doing a pull request in GitHub. Test automation code can read this file before any tests start, and they can inject input values as appropriate to the tests that need it. For example, using this JSON file, automation could read the browser type and, let's say, construct a Selenium WebDriver object for Chrome. Or if you're really cool and hip, you're doing Playwright now. The path for the input file would need to be hard-coded into your tests, but that could be as simple as a standard file name in your current directory. No biggie. Another way to handle your inputs could be with environment variables. Testers could set variables from a system shell or profile, and automation could read those variables by name. Fairly standard practice, especially useful for continuous integration servers and Docker containers. However, it can be a little more dangerous because you can change values at any time. You need to make sure you control that well. But again, no diff here. Automation can read these environment variables in, handle them appropriately. In the past, when I've done this, I've used like .env files in my test projects to save them. Makes it really useful. The one downside of the environment variable approach is that unlike JSON or YAML, you can't really truly be hierarchical, right? You're kind of flat in your hierarchy. If you've got complicated inputs or config, you might want something like JSON or YAML. All right, so let's remove that hard-coded step from browser type. God, better practice. We can handle that as an automation concern. Next, let's look at a second type of test data. Notice how the URL here is hard-coded. That's also not a good practice. Typically, development teams host multiple instances of products under development, like a developer environment and a staging environment and a beta environment and whatever names you want to give your pre-production environments. Hard-coding configuration information like this limits where your tests can run. Any information about a product's config is called configuration metadata. This includes things like URLs, usernames, passwords, and possibly other descriptors. And the bigger your system is, the more config metadata you typically find, so the more of a nightmare it is to try to handle this well. There are a few ways to handle config metadata. You could use those flat files or those environment variables like we did for test control inputs. However, I recommend in this case using flat files, and I also recommend separating your test control inputs from your configuration metadata. Create an input to refer to your target configuration and then store multiple configurations in config metadata files. So that way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you could store these config files or values in cloud-based secret service like Azure Key Vault or Doppler or whatever the equivalent is in AWS. They all have one. This would be especially helpful for keeping secrets like your password safe. However, setting up such a service may be overkill if your project is small. Either way, the test step can be rewritten to refer more generically to the web app. Automation can select the target environment using inputs and config metadata. The remaining pieces of test case data all fall into the category of test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. And even in this classification, there are subtypes. First kind of test case value is a literal value. These are values that are hard-coded in the test. In this example test, the table of personal info contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case itself. The literals in this info table will be entered as input values into the web app. And really, they could be any values. It doesn't matter that you've got Freddy Krueger on 1428 Elm Street. The second kind of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they're the outputs generated by exercising a behavior. In this example test, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify that it was correctly submitted. These values cannot be literals because they originate from the product. Tests must refer to them by reference and retrieve their values from the product. Does that difference make sense there? Yeah. Side note, this test dynamically creates the loan application. This is an example of the dynamic product data preparation that we covered earlier. All right, the third and final kind of test case value is the trickiest, the input reference. At first, these may look like literals. However, input references are values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, this test has an input dependency. it must specify the type of loan, and the loan type it specifies must already exist in the product data. The simplest way to write this test is to simply hard code the reference, as we've done here. The name home mortgage, quote unquote, refers to the name of the loan type in the web app. Automation can use that name when selecting the loan type from a button or dropdown. Hard-coded references make it easy to write tests, but they require statically prepped data to exist in the system. References also become hard to maintain when the product data changes, or when the same test must run against ever so slightly different configurations with different names. One way you could avoid this is you could try to dynamically create the loan or the home mortgage loan type in the system, but let's say that takes too long. We know the pain points, so we're stuck with input reference. A more robust solution than just hard coding a reference like this could be data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard coding the name of the desired loan type, the test could describe the loan type and then use automation to search the web app's config to find a loan type of matching desired criteria. For example, if different regions of a bank have different names for this type of loan, the discovery mechanism could look in the config for a satisfactory home mortgage loan type and return the specific name for that current bank region. Discovery enables tests to search existing product data for required records instead of hard-coding records. Discovery makes tests more resilient to changes in that product data. It's great when you're testing multiple environments with those ever so slightly different configurations between them. But this strategy does require extra coding, and it may be overkill for small projects. So that's a lot of information about test case data. In summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configurations for the target environment. They should be supplied via config files and secrets holding services. Test case values direct the behavior covered by the test. They may be literals, output references, or input references. And those input references, they may be hard-coded or discovered. Now at this point, you're probably thinking, man, that's a ton of information. Dang, way too early in the morning for that. But that's it, right? We're done. It's time for Q&A. Let's go play with puppies. Sorry, folks, the nightmare's not over yet. Sorry, I don't make up the rules. There's one more problem to address, and that's collisions. Collisions, they happen whenever multiple actors operate on shared resources. So in layman's terms, if you've got multiple testers trying to hit the system at the same time, or when you're running your tests in parallel. Additional considerations must be taken to avoid collisions, because this can really ruin your test project. First and foremost, isolate your environments. Please, isolate your environments. Isolate your environments. Who here isolates their environments? Yes. The rest of you don't, please isolate your environments. Prevent external actors from interrupting your tests. If you have shared environments, block others from accessing the system when tests are running. You might need to schedule tests to run during off hours, like overnight. You might also want to set up multiple environments, or if you haven't already done so, containerize your environments. I love containers because it guarantees perfect isolation. Secondly, treat any shared data as immutable. Sometimes shared product data is unavoidable. For example, if you're running tests in parallel against one instance of a system, or if an application has multiple components, certain components might be difficult to isolate for testing. Whenever data must be shared, treat that data as constant. Any changes in shared data could break tests. For example, if you have one test that uses a car loan and another test that deletes the car loan type from the system, what do you think is going to happen? Kaboom! The Beetle crashes. Very sad. Any test that must alter shared data should be run serially instead of in parallel, and they should always undo any changes they make. Third and finally, use dynamic data prep as much as possible, because tests can't collide on data they don't share. Keep that static prep data to a minimum. Statically created data is more likely to become shared, and shared is more likely to cause collisions. So now we've reached the end, and we've covered a lot of information in this half hour. Just in quick summary to recap, we got two types of test data, product data and test case data. Product data can be prepared statically or dynamically. Test cases either control how tests run or they reflect product data. We should always handle our references and shared data very carefully. And overall, choose the strategies to defeat your nightmares. Every product is different. Every team is different. You might not be facing the same nightmares as someone else. My goal is not to be prescriptive, but descriptive. So now that we know all about test data, I encourage you to pick the best strategies for your needs. Thank you all very much for listening to my talk today about test data. Thank you. Again, my name is Andy Knight, Pandy Knight. I'm the Automation Panda. Be sure to come talk with me afterwards. Check out my blog, all the good stuff.